researchers have developed a data transfer system that can transmit information 10 times faster than a USB. The new link powers high-frequency silicon chips with a polymer cable as thin as a strand of hair. The system may one day boost energy efficiency in data centers and lighten the loads of electronics-rich spacecraft. The research was presented at IEEE International Solid-State Circuits Conference. The need for snappy data exchange is clear, especially in an era of remote work. There is an explosion in the amount of information being shared between computer chips, cloud computing, the internet, big data. And a lot of this happens over conventional copper wire. But copper wires, like those found in USB or HDMI cables, are power hungry, especially when dealing with heavy data loads. There is a fundamental trade-off between the amount of energy burned and the rate of information exchanged. Despite a growing demand for fast data transmission beyond 100 gigabits per second through conduits longer than a meter, the typical solution has been increasingly bulky and costly copper cables. One alternative to copper wire is fiber optic cable, though that has its own problems. Whereas copper wires use electrical signaling, fiber optics use photons. That allows fiber optics to transmit data quickly and with little energy dissipation. But silicon computer chips generally don't play well with photons, making interconnections between fiber optic cables and computers a challenge. There is currently no way to efficiently generate, amplify, or detect photons in silicon. There are all kinds of expensive and complex integration schemes, but from an economics perspective, it is not a great solution. So the researchers developed their own. The team's new link draws on benefits of both copper and fiber optic conduits, while ditching their drawbacks. Their conduit is made of plastic polymer, so it is lighter and potentially cheaper to manufacture than traditional copper cables. But when the polymer link is operated with sub-terahertz electromagnetic signals, it is far more energy efficient than copper in transmitting a high data load. The new link's efficiency rivals that of fiber optic, but has a key advantage. It is compatible directly with silicon chips without any special manufacturing. The team engineered such low-cost chips to pair with the polymer conduit. Typically, silicon chips struggle to operate at sub-terahertz frequencies. Yet, the team's new chips generate those high-frequency signals with enough power to transmit data directly into the conduit. That clean connection from the silicon chips to the conduit means the overall system can be manufactured with standard, cost-effective methods. The new link also beats out copper in terms of size. The cross-sectional area of this cable is 0.4 millimeters by a quarter millimeter, so it's super tiny, like a strand of hair. Despite its slim size, it can carry a hefty load of data since it sends signal over 3 different parallel channels separated by frequency. The link's total bandwidth is 105 gigabits per second, nearly an order of magnitude faster than a copper-based USB cable. The researchers suggest data-dense applications like server farms could be early adopters of the new links, since they could dramatically cut data centers' high energy demands. The link could also be a key solution for the aerospace and automotive industries, which place a premium on small light devices. And one day, the link could replace the consumer electronic cables in homes and offices. It is far less costly than copper or fiber optic approaches, with significantly wider bandwidth and lower loss than conventional copper solutions.